Hey, Vlad here, devinside.com. Welcome to another video. Slightly more than half a year ago, I made a video about unit testing, and in that video I mentioned property-based testing, and almost immediately I received a request to make a video about it. I knew even back then that it wouldn't be so straightforward to make a video like that without explaining implicits and type classes first. And now that we have those topics covered, we can finally start talking about property-based testing with ScalaCheck. Let's do this. Alright, we have a lot of ground to cover, so let's get started right away. First of all, let me say that there will be two videos. This one is going to be about ScalaCheck, and the upcoming one is going to be about Scala tests integration with ScalaCheck, and even about the upcoming Scala tests independence from ScalaCheck. Now, before even explaining what property-based testing is, allow me to point out that property-based testing is an extremely powerful concept, but this video is just a crash course, so please don't be disappointed if you walk away from this video not really grasping the importance of the topic. When the time comes, we will cover it more in depth for sure. For now, all we need to know is what it is it for, and how to get our hands dirty with ScalaCheck. Alright, what is property-based testing, and what other bases for testing are there? There are many kinds of testing out there. The most prominent ones are unit tests, component tests, integration tests, and acceptance tests. But we're not going to compare property-based testing against any of them in particular. What we will do instead is we will compare property-based testing against all of them at the same time, because all of them are based on examples, whereas property-based testing is based on, well, properties. So there are two bases for testing known to me: example-based and property-based. Let me give you an example of an example-based test. Yes, absolutely, pun intended. If you've been following me for a while, you've seen me writing many unit tests, which are the simplest example of example-based tests. You throw a few example values at a function and expect a very well-defined result back, which itself is an example in its own right. And if you haven't been following me, well, then what are you waiting for? Subscribe if you want to improve the developer inside you, or at least watch the unit testing crash course, which I mentioned in the beginning of the video, before watching this one. Now, in contrast to example-based testing, you define properties or characteristics of a function, and then your property-based testing library, ScalaCheck in our case, will generate potentially thousands of possible input values, put them in, and after a configurable threshold of successful runs, your test will succeed. For historical reasons, the threshold is 100, but again, it is configurable. And successful means that the property held for 100 successful runs. So ScalaCheck will try as hard as it can to falsify your property, and it will simply give up after 100 successful tries. Now, before diving deeply into details, let me show you an example straight from the ScalaCheck website. And yes, again, pun fully intended. So if we go to scalacheck.org and we scroll down, we see a quick start over here, and we see this example over here. Don't pay attention to all this syntactical noise. We will go through all of that very slowly in just a few minutes. For now, I just want you to have something visual so that you get a feeling for property-based testing. So we get some object string specification, and it extends properties of string. This is just a name. So basically, this is just a suite of properties, and we have three of them, 1, 2, 3. So let's talk about this very first one, okay? So this part just says that this is a property, and this is the actual body of the property. And it says that for all pairs A and B, which are strings, for any two given values for those two strings, if we concatenate them, then whatever comes out should start with A. Since our threshold is 100, ScalaCheck will generate 50 values for A, 50 values for B. It will stick them into this lambda over here, right, which returns a Boolean, and like this thing is a Boolean, right? This is the regular method on string. And this Boolean will be converted with an implicit conversion into something called prop, which is basically property. A prop is a class defined in ScalaCheck. In fact, I will show it to you right here. Before I'm going to show it to you, I prepared all the important places. They're open in the browser. But if you're exploring libraries like this on your own, you're better off using a proper IDE like IntelliJ, for example. So far, I have been only using Sublime Text, which I prefer. I don't really like those really heavy IDEs, but denying that they have a value is very ignorant. So when I was preparing this video, I myself was using an IDE and IntelliJ to jump in and to see how everything works out. Because what you see here, even for me who has more than 8 years in Scala, this is a pretty heavy DSL with a lot of implicits, with a lot of overload, overloads, with a lot of new concepts, so use an IDE. So ScalaCheck is open source, so if I click over here, we're actually going to end up in github.com for Ricky Nils, which who is a creator of ScalaCheck, and somewhere in the prop Scala file, probably in the companion object, there is a implicit def, which just takes a boolean and produces a prop, right? So it just passes this boolean to the prop. And if I click to the next place, which is in the same file, by the way, it's line 316. By the way, if you're on GitHub, if you just press L, it will allow you to jump through any to any line you want. For example, to 400. If I press L again, we're going to go back to 316 it was, right? All right, so this is where the boolean ends up, and this is how the property is being constructed. So if the boolean is true, it will just give you back proved, and otherwise it will give you back falsified. And both of these are in the same file at line 379, and they're over here. It's just a lazy val proved, which is just a property, which is just some case class somewhere, right? Which is constructed with other case class called result inside of it, and this one has a status, and this is probably some ADT, some values. One is called proof, the other one is called what was the other one? Falsified. The other one is false, right? So we got proof and we got false, but this is going too deeply already into the implementation, and we're going to go through that slowly a bit later. It's just that when I'm learning new libraries, I really want to understand how exactly they work. I don't want to understand like every little thing to the detail, like every little mechanic, but this big thing, like what can I actually stick into this for all so that it will work, because it turns out that most of the time you can only stick booleans. Maybe there's some other implicit conversion laying around somewhere, but I didn't find it, right? So I think all you can put into for all are booleans, right? And then they will be implicitly converted into properties. All right, so we're going to see where the values are coming from in just a few minutes. Trust me, by the end of this video there will be no magic left. As of right now, you should know so many Scala concepts that you should be able to understand ScalaCheck almost entirely. There are maybe one or two places that you might not get right away, but these are not essential. Okay, so for now, let's just take a look at the two other properties. The second one has two booleans, which are combined with the AND operator. This is a standard Boolean operator, right? So if you have, again, A and B, right, then if you concatenate them, then whatever comes out should be longer than either of them, right? So it should be longer than A and it should be longer than B. We're going to start running these properties pretty soon, and you will see that this property fails pretty fastly. Now, ScalaCheck, like most property-based driven libraries out there, which are all descendants of QuickCheck, by the way, in Haskell, invented in 1999 by Cohen, Klassen, and John Hughes, are very good at generating edge cases. So one of the first things that ScalaCheck will try is to generate empty strings. And if you put two empty strings together, whatever comes out, which is an empty string, is not longer than the first two initial empty strings. The size will remain 0, so this property has defects. Now, obviously, you don't want your properties to contain bugs, so this is done here only for demonstration purposes. But your test, as always, can fail for the typical 4 reasons. There is either a bug in your production code, or in your property, or in your test, or in your testing library, or in your runtime, or in your compiler, and so on and so on and so on. So it's actually way more than 4. What can I say? Programming is really hard. The last property is pretty straightforward. This time we're generating 3 strings. We concatenate all of them together, and then we cut out a part from the place where B starts to the place where B ends. And so whatever should come out will always be B, even if all the strings are empty. By the way, the name for the for all method and also the logo for ScalaCheck are coming from the thing called universal quantification, which is a concept in predicate logic, which is also present in type systems. For example, the type constructor list of t will work for any type t, so it will compile for all type t's. For all. Now, there also exists a method called exists in ScalaCheck, right? So instead of for all, you have exists, which also has a correspondence in predicate logic, which goes by the name of existential quantification. And it also has a twin brother in type systems, but this is a bit harder because it's based on dependent types, and we haven't talked about that at all. And we're not going to talk about this today because most of the time when you're writing property-based tests, you want to use the for all method. All right, now that you have something visual in front of you, let me talk a little bit about property-based testing before we get our hands dirty with ScalaCheck. Since property-based testing is just a different style of testing, contrasted with example-based testing, you can use this style for writing unit tests, component tests, integration tests, and acceptance tests, and so on. And quite frankly, you should. There is a lot of value in property-based testing. Having said that, example-driven tests also have value, and here are 4 reasons that I could come up with to support this argument. Number 1. Example-driven tests are easier to write. Coming up with meaningful properties takes a bit of practice and, in fact, a slight mind shift. In fact, a lot of programmers to this day claim that even writing example-driven tests is hard, and they use that as an excuse to not write any tests at all. Number 2, example-driven tests are a better tool for incrementally driving algorithmic design. For instance, let's say that you want to implement a microwave. In my opinion, it is much easier to say, okay, if I put a glass of water in, then this should happen. And then if I put a glass with a chocolate drink, then this should happen. And if I put a plate with rice, then this should happen. And then if I put a plate with chicken, then this should happen. And only once I have all of these tests, then I can maybe even replace or add a property which says, okay, for all liquids, it should behave like this, or for all plastic containers it should behave like this, or for all veggies it should behave like this. In fact, many programmers write their programs this way. They test drive their implementation with example-based tests, example-based unit tests, right? And then properties start to appear, once they actually understand what the hell they're building, and then maybe sometimes you actually end up throwing out all your unit tests because they just became obsolete. Number 3, not only is it easier to write example-based tests, it is also easier to read them. Be honest to yourself. If you take a look again at this property, what is your mind trying to do? It is probably trying to do what ScalaCheck is supposed to be doing for you. Your mind is trying to come up with examples to falsify this property. My recommendation is to leave a few example-based tests in there, especially for edge cases, especially for the edge cases that the property-based test found. So just take them, leave them in there. Number 4, which is based on all of these 3 combined. Example-based tests are the language that will be used in meetings, especially when non-technical people are involved. Think about how the business people usually talk about user stories. When I put my teacup into the microwave, then I press a button, I want it to be warmed up, and I want to get an email when it is warm. Now it is your job to take this example and ask questions to even consider converting this into a property. What if there is no water in the mug? What about other mugs? What about coffee? What about tea? What about chicken? What about rice? No email? Same email? Different email? Property-driven tasks are too abstract for people to come up with, especially if they're not technically inclined. All right, on the other side of the story, when would you choose to start with property-based tests? Number 1. The original test framework, QuickCheck, was written for the programming language Haskell, which is a highly functional language. So to this day, property-based tests have a very, very low cost for testing functional constructs, especially the ones that have their roots in math, because math has laws. And even though you can't prove those laws with property-based tests, you're definitely way better off by allowing your library to generate a bunch of examples for you. Because, and I hope that this should be obvious by now, one property-based test can replace multiple orders of magnitude of example-based tests. Number 2, because the cost for testing functional constructs is so low, you also automatically get a lot of value out of it. However, interestingly enough, you actually get the most value of property-based tests when you're testing concurrent or at least imperative constructs. And yes, I use both of those terms in the same sentence. Now, we haven't discussed concurrency on this channel, but we will one day, and you will be surprised how easy it is to find very, very sneaky race conditions with property-based tests. When it comes to concurrency, property-based tests are a lifesaver. By the way, in the beginning of this video, I said that there will be 2 videos. There will be, in fact, a third one in a relatively distant future, though, in which we will build models for stateful computations and compare them against the real systems. That video is going to be about advanced property-based testing, and this one is just a crash course. Number 3, Example-driven tasks demand a certain degree of determinism from you. And in fact, I'm not even sure if determinism is the correct word. What I mean by that is when you want to provide examples for your task, you also need to precisely determine the result that you expect. But this is not always possible or desirable. For instance, imagine testing some complex calculation like weather or Texas, for example. These calculations tend to have tons of variables, and in your test you will probably try to modify one of these variables and expect it to have a direct causality on your result. However, because the algorithm is so complex, it will probably end up in multiple different branches, and it will modify the result in such a way that is really hard to predict. However, with property-based tests, you can just say, okay, so if this variable is greater than this variable, then whatever comes out should be for sure above this certain threshold. So you don't have to come up with the exact example. You don't have to do the entire calculation on paper, for example, just so that you can put this number in your test. Number 4, which is mostly based on number 1 actually. Since property-based tests can replace orders of magnitude of example-based tests, they can also find multiple bugs at the same time, right? So one property can find multiple bugs. So property-based tests are masters of fighting the combinatorial complexity that example-based tests suffer from and most programmers complain about. All right, let's finally write a few tests ourselves. As always, we're in the Ubuntu virtual machine and we're writing Sublime Text, which is the editor of my choosing, which is fully maximized, and we're using a wonderful plugin called Terminus, which is running here at the bottom, which allows us to emulate the entire terminal, which we use to run SBT, which reruns our tests or properties every time we save the file. So I already have a project prepared for you. Let me just run through it real quickly. This is just a Hello World project. So we're using SBT 1 to 8. We're using only one plugin, Scalariform, to format our code. These are the Scalariform settings. Pause the video if you want to look through them, but these are the same ones as I'm using in most of my videos. And build SBT, all we're saying is that we don't want the server, we're using Scala version 2.12.8. Every time we're using continuous compilation or continuous running of tests, the output should be cleared. For example, if I just go over here, I save the file, everything was cleared, and the output starts over here, right at the very top. The next thing that we have in the build SBT is we have the library dependency, which is copied straight from the ScalaCheck website. Let me actually show it to you over here. So it's just this one line copied and pasted over there. And we're also setting some options because I just wanted to show you these options. Okay, so usually when you set options for your testing framework, you have to specify which framework it is for. And by the way, this is a new syntax in SBT1. So before that, you would say test options and test, right? And then you would say plus equals and so on and so on. Okay, so in fact, this setting specifies that we don't want to run hundreds of tests. We want to run only 10, right? So as you can see over here, we say it says pass 10 tests, passed 10 tests. If I change this to 100, reload the project, it will be 100 again by default. So I only did this just to show you how the settings work. In fact, I'm going to remove this right now, and I'm going to reload the project, reload, and in the meantime, I'm going to show you the property-based suite. Hold up, let me just say test like this again. Okay, so we see now that it's 100 pass tests. So what I did over here is I literally just copy pasted the example from the website, and I pressed enter over here, so so it looks a little bit better. Okay, so this is exactly the same code that we just found on the website. So let me actually go to the website real quick, and I will show you that over here at the very top we have a button with documentation. So if you click on that, then there's also a user guide over here that I already have open here, but I'm just going to click on it. So the user guide is posted on GitHub, and if you search for minimal test case minimization, there it is. Then right above it, you see the section which explains all of these options. So this is the one that I just used. For example, I used the -s, and I specified how many tests I want. So you can also specify, the number of threads, or the verbosity level, all of these other things. You can just play around with them, and you can specify them as you have just seen. Okay, right. So let's go back to the VM. All right, so ScalaCheck is basically on the same level as other testing frameworks, so you can use the test command in SBT, right? But also this extends properties thing, it also has a main method. So what you can also do is you can just go test run, and it will just run the main method, which is over here. But then you don't have the colored output, but you know, it's basically doing the same thing, right? We're not going to do that though, so we're just going to go back to testing, and also I'm going to collapse the sidebar like this, and I'm going to minimize that a little bit. Okay, let me save again so that we see only the last output. There we go. All right, so let's talk about the output a little bit. So as you can see, the entire test suite that ran, it failed. And this is a summary. We had three tests in total, or three properties in total. One failed, there were 0 errors, and 2 passed. Now the ones that passed are over here, the green ones. You see a plus in front of them. You see they start with string because we specify a string over here, and starts with and substring are coming from the names over here. Starts with and substring. Okay. And we passed 100 tests. Now this one called concatenate, it was falsified after 0 passed tests. So right away, one of the very few one of the very first values that ScalaCheck tried to generate were the values of empty strings, right? So arg0, which is 8, was empty. Arg1, which is actually B, was also empty. It put them over here, and then the entire property failed. So in fact, if you fix that, if I put an equal sign over here, if I put an equal sign over here, by the way, this is Fira code. If you don't know what Fira code is, I already made a video about this. It just renders your programming code more beautifully, right? So if I save the file now, then the test will actually pass. All of the 3 tests will actually pass. So it says pass, total 3. Everything is green, everything is good. Now, this syntax over here is actually very, very tricky, and I've never talked about this because usually on the left side, you either have the name of the variable or maybe a pattern, but over here, it looks like we're calling a method and that we have the equal sign. Now, you're probably thinking that this is a way to register these properties with something inside of properties, and you're right, but I'm going to show you how exactly this works. Before that, let me point out that these property-based tasks, you can actually run them individually. I'm not going to show you this because most of the time, you know, if you mean business, then you will have those, you know, property suites like this. Okay, so I'm not going to show you this. It's not actually vital. Okay, so what I'm going to show you is I'm going to create a tiny method, a tiny main over here, extends app, right, like this. And let me save the file, and let me do print line hello world, and let me switch to running that. Okay, so I need to say test run like this. Okay, I want the string specific. Oh yeah, so as I said, you know, string specification is also a main. So let me run the main, and in fact, let me do instead, I want to do test run main. Do we have a package? I don't think so. Main, just like this. Okay, so we see our hello world over here. So Scala has this magical syntax. If you have the apply method defined on the class, then you don't have to call it. You know, you can just call it as a factory, right? So there's also another one, and this one goes by the name of update. So apply is magical and update is magical. So if you have a method called update, right, and let's say it gets some key, which is an int, and it gets some value, which is a string, and it produces a unit. It doesn't have to produce a unit. It can produce whatever you want, but usually it's a unit, right? And over here we just do a print line key, and we're going to do a print line value. Okay, then you can call this like this. This one equals 1. So what will happen behind the scenes is this. It will call this dot update with 1, and the value is going to be 1, right? So this is exactly the same code, right? So you see 1 1 1 1 2 times. Okay, so you can also obviously do main 2 equals 2, right? You can assign this to another variable. You can do m3 equals 3. It's all the same. Okay, so and this is the same as m dot update 3 with 3. This is a very magical thing. In fact, I don't really like this, but I know the reason why it exists. Okay, and the next thing that I'm going to point out is that you need to have at least 2 variables. Okay, so if you have first key int, second key string value string like this, produces a unit, and we're just going to do print line first key, and we're going to print line second key, and we're going to print line value like this. And then what you can do over, let me write it over here, right? So you can do am4 and then 4 like this, right? So we're specifying the first key and the second key, and only the last thing is the value, right? So only the last thing is going to be 4, okay? Like this. So you can't do, what happened? Oh, I'm using m. M doesn't exist here yet, so let's just do this. Okay, so this is gonna work, but this one is not gonna work, right? So you can't just do like 4, for example, and then try something weird like, I don't know, like passing a tuple or something like this, right? So this is not gonna work. Okay, so this was the tiny excursion into this update method. Let me actually remove that. Okay, like this, and let me switch back to running the test, and actually let me go back to the website. Because I found a place where this is done. So this is what's happening if you're calling properties. So what it will do is it will create this new property specifier, which is just a class which is defined over here, right? And then when you're calling update, you're just specifying the property name, and you're passing in a property which happens to be a by name parameter, and all that it is doing is it's doing some conversion, and it adds them into this map looking thing. In fact, it's not a map, it's a list buffer over here, right? So just props. Okay, so every time we're doing this, we're just calling the update method. Okay, now I hope that it's slightly less magical. All right, so now let's look at for all. Let me go back to the website again, and I found it over here. This is how for all looks like, and this looks pretty scary, right? But don't worry, we're going to go through everything over here very, very slowly. If we're looking at the signature, the first thing that we will start with is the return type. So for all, whatever it's doing, it produces a prop, right? And then the props are being registered with the property suite. And if you look at this, what is happening here, it's calling for all again. In fact, it's calling another overload of for all, this one, right? So what is happening here is basically function curring. So this code is just calling this one. So you can basically nest them. In fact, let me show this to you. And by the way, these parameters, they're called A1 and A2, and they're getting stuck into this lambda A1 and A2, and we're producing a property, right? And how are we producing the property? Well, we're passing a P, which in our case is a Boolean, and then we have seen already this implicit conversion, which is over here, right? It just takes this Boolean and converts this into a property. Okay, we're over here. Okay, so I'm just saying that the type parameters are called A1 and A2, but we're using actually A and B. Okay, just so that you're less confused. So let me explain this to you. So in fact, the test that we have written here starts with, which calls for all with 2 parameters, is exactly the same thing as saying, okay, property starts with, I'm gonna say 2 equals, and I'm actually gonna press enter over here. It's the same as saying, okay, for all. And now I'm going to use A1 and A2 instead of A and B, okay? I'm going to say A1, which is a string, arrow to the right now, and then we call for all again, right? For all again was A2 string, okay? This starts to resemble the monadic design again, right? So have A1 plus A2. By the way, soon I'm going to make a video about monads because, they keep popping up. So I better make a video about them. Okay, so starts with A1, right? So this is basically exactly the same code as above, right? So all of them passed. Exactly the same thing, right? So you just have like a bunch of these overloads that are helping you, so that you don't have to write this because this is more code. You can just write this. All right, so let's go and look at this signature again. So let's actually talk about the signature. So as I already said, for all once, for all is a current function. So it has one parameter list and the second parameter list, and the entire second parameter list is implicit. And by the way, guys, if this is still a bit too magical for you, be sure to watch my previous videos about implicits and type classes, okay? So as I already said, it wants a lambda which has parameters that you want ScalaCheck to generate a bunch of values for you, right? And this lambda has to produce a property. How is it going to produce a property? You're just going to give it a Boolean, and the implicit conversion is going to kick in. It's going to convert the Boolean into a property. All right, so how does ScalaCheck generate those values? Well, it does that because there will be an implicit instance of the arbitrary type class. And an arbitrary type class, it is just a wrapper around generators for something. For example, in our case, it's strings. So it needs 2 generators in this case, A1 and A2 are the same, they're strings, so it wants two generators for strings, and they're wrapped in arbitrary. So generators are called gen in ScalaCheck, and quite soon you will see the difference between arbitrary and gen. In fact, I find this part of ScalaCheck a little bit confusing. Having said that, I probably find it confusing because I didn't dive too deep, because ScalaCheck seems to be an almost straight copy from QuickCheck, of QuickCheck, and QuickCheck is doing it the same way. So there are gens and there are arbitraries. Now, the next two things are shrink. These are so-called shrinkers, and what they do is basically it's just cosmetics. So we're going to get to shrinking in just a few minutes, but essentially if ScalaCheck manages to falsify your property, it will actually backtrack a little bit, and it will try to falsify it again with examples that are smaller, whatever smaller means. The last one, I didn't dug too deeply into it. So we have two views over here. The first view is that takes your P, which is most of the time a Boolean, and converts into a property. And the other one is the view that takes your A1 and converts into a pretty, and A2 and converts into a pretty. I didn't look into this, but I'm just assuming that this is just for pretty printing the output results, right? So testing frameworks are there to make sure that you have less bugs, right? So for quality assurance, but this is not their only job. Their second job is also to present those results in such a way that you can fastly spot them with a human eye, and you can fix that. You can fix your code. All right, so let's start playing with the generators and see actually what ScalaCheck pulls out of its sleeves for us. All right, so let's go back to the VM, and let me remove this one. Okay, and in fact, let me comment out these ones because I haven't figured out how I can ignore properties in ScalaCheck. All right. So we're going to have this one, and what I'm going to do is I'm going to go over here. I'm going to say print line A and print line B. And by the way, we don't really care about the property, so I'm just going to put a true in here, right? So as long as it's true, it will be converted into a property, and ScalaCheck will be happy. Also, let me add in the print line for my favorite hyphens. I'm going to make these hyphens famous, right? 2500 times 50, like this. And let me copy one of these hyphens so that it's easier to read over here, like this over here. Now, in fact, we're running 100 tests. You know what? Let me go back to the build. Press Ctrl Z a few times. Let's run just 10 tests. It's gonna be easier for the to understand the output. Okay, so let's reload, and let's run our tests again. And let me make this bigger so that you see that we had only 10 of them. In fact, maybe let's even go to 4. It's just going to be much more simpler. Okay, let's go like this, reload. Okay, test again. Let's make this a bit bigger, like this. All right, let me save the file. This one, save the file. All right, so we see a few things. The first thing is that ScalaCheck is obviously racist. Just kidding. So as you can see, like when you're writing example-based tests, you're never going to come up with examples like this, right? You're never going to come up with examples that have like empty strings in the middle, or have like, I don't know, Korean or Chinese, some Asian symbols. Sometimes they will, if I had generated more of them, you would see that some of them would start with empty strings, that they would contain line breaks. This one is entirely empty. All right, so we're not going to see exactly how these values are being generated, but we're going to, start playing with generators a little bit, because ScalaCheck comes with a lot of already like pre-built generators, and also factories for creating your own generators. So we're going to go back to the website. We're going to go up. This is the user guide actually. Let me go and click on documentation, and we're going to click on where is it? Online over here. So this is the API for ScalaCheck. All right. So as you can see, there is a arbitrary class and a companion object, and there is also gen, a class and a companion object. So let me click on gen. If you click on gen, you end up in the class, and you can also click on O over here to get into the companion object. Or if you see this symbol over here, you can just click on this C, and it will land you in the companion object. You can click again, you will end up in a class. All right, so this is the companion object, and as you can see, there are a bunch of methods here that return a gen of char, a gen of string, a gen of t, sequence of t, and all the others, right? So if, for example, we search for something that ends with a colon of gen string, right? Then we will see, okay, there's alpha lower string, there's alpha num string, there's alpha string, alpha upper string, and so on and so on. By the way, notice that the documentation there is for Scala 2.11, and we're already at Scala 2.12, but nothing major changed in the front end of the language between 2.11 and 2.12, so don't worry about that. This is going to be, pretty accurate. So if you scroll a bit more down, you will see that, so these are already pre-built generators, but there are also some of them are actually factories to build another one. For example, this one is called frequency, this one is called const, this one is called delay. I'm also looking for one-off. There's one called one-off, option, parameterize, pick, and so on and so on and so on. Okay, but before playing with these, let's actually play with a few built-in ones. So let's go back to our code. So what we can do here is we can go over here, right? And we can say val gen, which is a gen of string. And by the way, let's fix the imports. Like usually you would do something like this and something like that. Okay, so we're importing everything from ScalaCheck and from prop. Okay, so and we go and we're going to say gen dot alpha num str. And by the way, this is also where IDEs help with auto completion and stuff. Okay, so we were expecting this one to be used, but it's not being used. So let's see, what if we make it implicit? Still not going to work. So it works. It doesn't work because remember, for all wants arbitraries. So if you have gens, you actually have to stick them in like this, gen. You're sticking two of them because we need one generator for this string and one generator for that string. Okay, so if I save it now, then we in fact see that this generator is being used. So how does this work? Well, it turns out that there is yet another overload of for all. I have it somewhere over here. Not this one, not this one. It's this one, right? So this is another overload for all. It looks almost identical, but the arbitraries are gone, and instead you have the gens. By the way, I sort of forgot to mention that. So for both of these for alls, in fact, there's also a third one and a fourth one, but these two are the main ones. The one that takes the generators and the one that takes the arbitraries. For both of them, you have 8 overloads, right? So you can put in up to 8 different strings or ints or whatever, right? So see here, this one goes until 4, this one goes until 5, and it goes all the way until T7, T8, and that's it. This is where it stops, and then another kind of overloads begins. Okay, so you can go up to 8 things over here. Okay. All right, so why do we have this difference between arbitraries and generators? And quite frankly, I don't know. I have a suspicion. That the philosophy is that there should be only one way to generate arbitrary strings. As soon as you have another generator for strings, it's probably not generating exactly the same strings, right? It's probably some subset, right? So they're not arbitrary anymore, right? So there should be only one, and therefore you can mark only one as implicit, and then Scala will, punch you in the nose if you have multiple of them laying in the same scope. So essentially, if you want to use your generator as an arbitrary, all you need to do is you need to wrap it in an arbitrary, right? So you can go over here and you can say arbitrary, which is a nope, it should start like this, which is an arbitrary of string. Well, it is just an arbitrary, which it has a constructor where you can just pass in the gen, right? So now if you make this one implicit, you actually don't need to have this one implicit, then it will be picked up over here by the for all overload, and now it is being taken. All right, so if you want to get a hold of the default arbitrary instance, there are multiple ways. So the first one is if you know its name, right? So if you can go to arbitrary string, so in the companion object for arbitrary, right? We could go to the documentation right now, but you could see that there is one called arb string, right? And we will end up with the Asian characters again. In fact, I have to make it implicit like this. Okay, so this is the one that is being used. Okay, and the other way is basically by using implicits, right? So you go over here, you say implicit val arbitrary 2, which again is an arbitrary of string. You can just request it implicitly like this, arbitrary, basically give me an arbitrary of string, right? So these whole type class is basically trading names for types. Okay, so you can do this, right? So it's going to be the same thing except for raising property evaluation. What happened? I have no idea why this is not working. But in fact, let me show you there is a way to get the generator out of your arbitrary. Okay, so if we have a val g, which is a gen of string, right? So if you already have an arbitrary, then it would be cool if you could just say arbitrary.generator, right, or arbitrary gen, but for some reason they also called it arbitrary, right? So you have to say arbitrary.arbitrary like this, right? And now you can use this generator over here, right? G and G, okay? So in fact, if we use our own, hold up, if we use our own like this one, let's not make it implicit. Okay, so it's the same result, right? So we have our arbitrary, which is based on this gen. We're getting it out again. Okay, and it works. Let's see actually if this works again with this. If you don't make it implicit, if we just have it as a val over here, right? Yeah, it's called arbitrary now, like this. Now it works all of a sudden. Why does it work now, but it didn't work was implicitly? That's so weird. Implicit? What? That is some bug somewhere. That is definitely some bug somewhere. Null pointer exception. No, that is weird. Huh. Interesting. In any case, let's not do it like this. And then, okay, let's just remove that. Another way to retrieve a generator straight from the arbitrary, right? So you can go directly. So if you have G2, a gen string like this, right? So you can go to the companion object of arbitrary. And again, like I wish you could say, give me the generator for string, but for some reason you're saying, you know, give me arbitrary, right? But what it produces is actually the G2 over there. Okay, so hold up, now it doesn't have an arbitrary. Let's do that, and let's use G2, right? So that you see it's exactly the same thing. No, it's not exactly the same thing because I didn't mark it implicit. Hold up, implicit like this. Okay, right. So now it's exactly the same thing. Okay, so there's a way to get the arbitrary, and there's a way to get the generator from that arbitrary, and there's also a way to get the generator directly. And this will be useful in just a few minutes when we're going to start creating our own generators by combining them. And as you can see, this part is really buggy, and this part is the part that I don't like about, you know, I don't like this distinction between arbitraries and between gens. In fact, in the next video, we're going to see how Scala Test is going to do this with the upcoming version. And over there, you only have gens and you mark them implicit, and it just works. Okay, I actually prefer that approach. All right, so let's start creating our own. Let me start by showing you a few typical ones. So if we replace this with gen, remove all of that garbage. Okay, so the first one that we're going to do is gen const, right? Gen const, I'm going to say hello, and now you will see that all of a sudden it generates just hello. The next thing, the other one that is useful is the one that I already showed it to you. It's called one off. So you can say hello world, right, or some other things. You can just you know, specify multiple of them, basically pass the var args of them, and it will sometimes generate hello, sometimes generate world. One off is super useful if you have ADTs, right? So if you have a sealed abstract class season, and you have object season, and you have case object winter extends season, and I'm going to duplicate it 4 times. So we have winter, spring, we got summer, and we got autumn, right? So now you can go down over here. You can go and say, in fact, let's actually do it over here. I believe it's going to work like this better. So if you go over here, you have your gen of not string. It's going to be a gen of season, right? And you just say gen dot one off like this, and you just go. I can probably do that. Copy, paste, and then have commas over here, right? So you have a gen, and you can also have an arbitrary, which is an arbitrary of season, right? And it's just an arbitrary of this gen. Okay, so what, it doesn't like that comma? Oh, why did I use these? These work only if you have one parameter. Okay, so now you have arbiters, right? So now you can go and you can generate a property for this just to play around. So I'm just gonna go over here. I'm gonna say a property. We're gonna say season, and we're gonna say for all, and then we're gonna go over here season, specify the type, because if we don't specify the type, then the compiler doesn't know which implicit instance to grab. By the way, I didn't mark it as implicit. I'm gonna do this in just a second. Okay, so let's do print line season, season, right? And let's just return true. And also let's do my hyphens. Let's do my hyphens over there. Okay, like this. I'm gonna comment this one out. Okay, so if I did everything properly, then this should not compile because I forgot to mark it implicit. So it's going to say, could not find implicit value for parameter A1. But if I mark it implicit because it's in the companion object, it hopefully will be picked up. Yes, it is being picked up. So as you can see, sometimes it generates autumn, sometimes summer, sometimes autumn, and so on and so on and so on. In fact, if I run it again, I want to see also the other ones. Yeah, we got the spring, we got the summer, we got all of them. Okay. Now there are many other useful factories for generating gens. You can obviously consult the user guide or the documentation. I can't cover the entire library over here, right? But these are the most useful ones. One of the very useful things to know about gens is that they are actually monadic. Now I have been avoiding to talk about monads on this channel, but they keep popping up, so I'm pretty sure that soon I'm going to make a video about monads. But for now, all you need to know about monads is that you can stick them into the for comprehension. And if you don't know what for comprehensions are, I already made a video about it. Okay, so if we have so we have seasons over here. In fact, let me create way more space over here. Okay, so we have our gens for the seasons. So let's go over here and let's say that we have a case class person, the typical case class. We have a name, which is a string. We have age is an int, and we're gonna have a favorite season, right, which is a season over here. Now what you can do is, and again, it's very typical to do this in companion objects, right? So if we're gonna go to person, okay, and it is very typical to have a gen for them over here, right? So it's going to be gen for a person, and now you can just start a for comprehension like this. Okay, so now you can say, okay, let me grab the name from the generator for the strings, right? And remember that this one, it doesn't grab the arbitrary string, it grabs the gen string, right? So this one is a gen string. Okay, and let's do the same thing for age, right? Let's go for arbitrary for integer, right? Let's grab the favorite season, right? Like this. Okay, it's gonna be arbitrary for season like this. And in fact, maybe I believe that this should work like this. I haven't tried it like this, but it should work, right? And then in the end, you can yield a person with name, age, and favorite season like this. Let's see if it compiles. Yep, it does. All right. So what you can do now is you can generate a property for people, right? So we have the property for seasons. Let me actually copy that over here. Let me actually comment this one out because I want to minimize the output that we have over here. Over here we have persons, and over here we have we have person, and this one should be a capital P like that. And let's see what is being generated. Nothing is being generated because I forgot about the arbitrary, right? So the same as above, we have implicit val arbitrary, which is an arbitrary for a person equals arbitrary of gen. Okay, like this. And as you can see, very, very beautiful people, which are really, really old with empty names, but at least they have their favorite seasons, autumn, 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 like this. The next part is going to be a bit magical, so it can get a little bit tedious to write arbitraries for case classes and for ADTs, because arbitraries, they don't have any logic, right? They always do like the default generation, so there's no need to type them out. So it's tedious to type them out. Now there is a library called Shapeless, which is a very magical library, and we're going to talk about it probably like in a year or so. And there's another library which uses Shapeless, and it uses Scala Check, and it's called ScalaCheck Shapeless, which allows you to very easily generate those arbitraries that will generate instances of your ADTs or of your case classes. So if I go to the documentation, where is it? So this is a library created by Alex. I'm not even going to try to pronounce the last name, okay? So all you need to do is you need to grab the library dependency, which is over here, like this. Let's go to our build file. Let's add it over here. In fact, let's actually do ++ equals here, and now we can start using a sequence. Okay, so we can do that. We can just have a comma over here, remove that stuff. Okay, so now we can do this like that. Okay, so we have this sequence. Now we can reload the project. Okay, so now we can run our tests. Okay, and so now we're going to go to the property-based thing. I'm going to remove the entire companion object for people, right? And actually, let me hold up. So let me comment out. So now we have two properties for seasons and for people, and both of them work. They compile, they do something. Okay. So now if I comment out the companion object for people, then this other one is not going to compile. We have one error. And if I comment out the Jan and the arbitrary for the seasons, then we should have two errors, right? So none of these tests work. So if you go over here to the top, and we can go back actually to the documentation, all we need to do is one import, this one import. And by the way, notice that the package is org ScalaCheck, so it's, you know, it's a very seamless integration. So we go to the top, paste this thing in, all of a sudden our tests are doing exactly the same thing. See? Generating people, generating seasons, all the things, everything works. So for the rest of the video, I'm probably going to comment it out, but just so you know, for generating default things, this is how easy it is. Just drop it in, one import, you're good to go. Okay, so let me comment this out again, and let me use ours, because I want to see ours like this, like that. Okay, there we go. All right, so let me show you also, like I have been doing like these property stuff, but what you can also do is, even if you don't have any properties, if you have a gen of something, right? So if you have, I don't know, let's say season dot gen, right? So I think I called it gen, right? Season dot gen. Then you can just call sample on it. Dot sample, right? And let's stick it into a print line. Print line, let's have a few of them, right? Right, so you get access to what the generator is generating, and notice that it actually generates an option, and I'm going to say a few things about this in just a minute. What I want to show you is how to create an actually useful generator for people, because you probably wanted to generate some useful people. Okay, so what I'm going to do is, let me switch this to person real quick. Person. Right, because the one for the seasons is fine, but the one for the people is not fine, right? So, for example, nobody has a name with these weird symbols, and with the line break in there, right? Nobody has a negative age, and so on and so on. So what I'm going to do is I'm going to go over here. I'm going to say proper gen of gen person, and I'm going to show you like an actual, this is how you would actually, create your own generators. Okay, so the first thing that I'm going to do is I want to make sure that the names start with a big letter. Okay, so with a capital letter. So I'm going to call it head. I'm going to say, okay, so give me a gen for an alpha upper char. Okay, and then a tail for the name is going to be gen of alpha string. So now I can create a name with just string interpolation, and I can say, okay, just give me the head and just give me the tail. Okay, and I can also say, okay, just give me only like the first 10 letters. Okay, let's just, it's just an example. Okay, and then let's do age. So the age is going to be jan.choose, and choose works with things that have a minimum and a maximum, and integers obviously have that. Okay, so you can say minimum should be 0, right? Somebody's like, an infant, only like 5 months old, for example, and the maximum is going to be 123. I Googled recently, the oldest person was 122 years old, so 123 should be good. Okay, and favorite season, we can just grab it the same as we grabbed it before, arbitrary dot season. Okay, so now that we have that, we can yield a person with name, age, and favorite season. Okay, so now if we go to our property dot proper gen like this, we will see that these are more likely to be actual people. This is obviously still not a real name, but at least it looks like a real name, right? So it starts with a capital letter, it's not longer than 10 letters, the ages are fine, the favorite season is fine, all good. Now, I don't really know why generators are returning options over here. I have a suspicion though, and my suspicion is that you can modify generator even further, sort of say on the fly. Okay, so over here you can say, so before you're calling sample, you can also modify the generator a little bit. You can say such that, which is just a method that is on the generator, and you can say such that age is less than 10, for example. Right, and as you can see, it failed to generate anything. Let's do 20. Yeah, see, now it managed to generate 30. So if you're doing too much, you will constrain your generator too much. And in fact, if you constrain your generator too much, then it will actually discard some of your tasks, and your tasks will fail. Let me actually show this to you. So let me comment this out like this. Okay, let's take this one. What do we have? People. We have people over here. And let me put this one in like that. Okay, so 30 is fine. Let's do 10. Okay, so as you can see, gave up after only 0 past tests. 21 tests were discarded. So basically, the generator failed to generate enough values for your test. So be very careful with constraining your generators like this. And by the way, another way to do this is by using so-called implications, right? So this is just a Boolean here, right? True. So what you can do is you can have another Boolean in front of it, right? You can say false, right? And then you use this weird arrow syntax like this. Right? So if you have this, it's going to say gave up after only 0 past tests. And if you have this, it's going to behave basically exactly the same as it behaved before. So the idea is that you will have some Boolean like we did before over here. Like, so for example, you can say the person that is generated, the age should be under 30, for example, right? And then it's fine. But if you go like too much, come on, to like 5, 1. I thought that it should still discard values. Okay, maybe this discarding thing is only happening if you're actually modifying your generator. So if you're just filtering some stuff out over here, it is actually not going to discard anything. So this is probably the preferred way to do this. All right, so let's start talking about shrinkers. So as I already mentioned, shrinkers, they're basically just cosmetics, and they whoa, okay, my neighbors are drilling something. All right, so again, shrinkers are basically cosmetics, and so what will happen is basically when ScalaCheck wins, which means if it manages to falsify your property, then it will backtrack a little bit and it will try to generate a few values that are smaller. So as an example, we're just going to write a property somewhere over here. I'm going to call it number, okay, and I'm going to say that for all number, which is an integer, right? All we want to do is we're going to say number is smaller than 1000, for example, okay, like this. What you see all of a sudden over here is this arg0 original. So originally it generated this this value, which is probably int max value. Actually, let me see. Print line. I'm just guessing, but it's probably the max value. Yeah, it's this one. It's this one that was there before, right? Yeah, see, it's exactly. Oh, come on. Click. Yeah, it's exactly the max value. So it went to the max value and they said, okay, it's going to fail. I managed to falsify this property. So it's going to go back now and it's going to try to minimize it a little bit. And it's going to try to approximate this 1000. So it doesn't know anything about the 1000, right? So it's just going to try, and then it's going to come closer. It was 1023, for example, or here 1056. Sometimes it's going to get closer, sometimes it's going to get further, right? So I'm going to, let's run it a few times. Okay, we're generating way too few tests. Let's go back and ask it to generate. Let's go with 100 again. Okay, so let's reload and let's run the tests. All right, so over here you see 1023. Let's run it again. 1027. This is too much. 1024, and so on and so on. You see it actually better if it tries to do this for lists. So if you have numbers, and we're going to do for all, and over here we're going to have numbers, which is a list of int, and we're just going to do something silly. We're just going to say numbers dot size is smaller or equal to 5. I want to show you the minimization because the minimization is going to be clear now. So originally it generated a list with 1, 2, 3, 4, 5, 6 elements. In fact, this is a bad example. Let's do it again. Here, there you go. So it generated originally a list with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. And then it started to minimize that list. It minimized the integers inside of the list, and it minimized the size of the list. So now you see a little bit better how visually what the shrinker is actually doing, because with numbers it's not actually super visible. The same as you can call sample on a Jan, the same way you can call shrink on shrink. So we can just do a print line shrink dot shrink, and we do 100, right? 100, and we do 50, and we do 10. Now, we haven't talked about streams on my channel so far, but we will actually pretty soon, probably like in a few months from now. But for now, all you need to know is that they're basically like lazy lists that can be infinite. So what you can do is you can just convert them into lists. Okay, so let's just go over here, 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 and just convert them into lists. And then you see the minimization sequence, right? So if it was to find the 50, it would try to minimize it by doing a negative 50, then half of it, then negative of the half, then half of that, negative of the half, and so on and so on and so on. So this is the minimization. And the same thing you would see a minimization of some list. So if you have a list of some numbers, I'm going to put some random numbers in there, and let's see how we're gonna hold on. What the hell am I doing? I should do a shrink, and we're passing in that list. One more like this, dot to list, not shrink like this. Okay, whoa, what is happening? Yeah, so you see a list of lists. So it will shrink it like this, then it will shrink it like that, then it will shrink it like that, and like that. So it generates a bunch of values like this. Let me actually remove this one because this one is a bit confusing. If we're actually creating people, right? So if we go to person, actually, let me show you this with numbers again real quick. So if we have the simple property for numbers like this, smaller than 1,000, then we see the falsified and we see that it was shrunk, right? We see that it was shrunk. Okay, so if you do the same thing for people, you might expect that the shrinker will work automatically as well. If you have a person here, we have a person over here, we have a person over here, we have a person.age over here, right? Let's see. So what you see over here is that, you know, it was also falsified, but there was no shrinking involved, right? So the shrinkers are separate from the generators, and we have seen it in the beginning, right? So the for all, the signature for all, it wants, you know, the arbitraries and it wants the shrinkers. So because they're separate, you actually have to generate them as well. So we have over here for person, you know, we have the generator, but we have no shrinker. So shrinking is a bit of an involved topic, but I'm going to just write this one real quick. So if you go over here and we're going to say implicit val shrink, then we're going to have a shrink of person. Then we're just going to say shrink, and we're going to have person like this. So we're going to have the shrinker, which is the implicitly shrink of int. Okay, so we're gonna have over here, we're gonna have shrinked ages. I'm only gonna shrink the ages. Okay, so we're gonna have shrinker dot shrink person dot age like this. Okay, and we're gonna have shrinked ages dot map person. Okay, so now we have a shrinker for person, which doesn't compile because required int to. Oh yeah, sorry, in my preparation I had a person was only the age. Okay, so let's map to person dot copy age equals the parameter like this. It's gonna work like this. Let's do a like this. Yeah, okay, so this works, and now you actually see the shrinking happening. And if I remove that, then you don't see the shrinking. But if we have the shapeless thing, then we'll actually see the shrinking again. There we go. So the shapeless library generates both the generators and the shrinkers. Okay, let me remove it again like this. As I already mentioned, shrinkers are a bit of an advanced topic, and if you want to learn more about them, I'm going to have a link down in the description to a nice blog post about them in Scala. All right, so now that you know the internals of ScalaCheck, you know about the difference between the arbitraries and generators. We have created a few generators, and we even touched on the topic of shrinkers. And now you sit down and you realize that we haven't even talked about writing good properties at all. I'm going to have a link down in the description to the blog post by Scott Blushen. It's a blog post and it's a video about how to write awesome properties for your property-based tests. In fact, I'm going to open it right now over here. So again, all the credit goes to him, and he says that there are a few categories for properties that he sort of came up with. There's the different paths. In fact, let me zoom in a little bit like this. Okay, so there's different paths, same destination, and he has a picture over here, and this is the typical commutativity thing, right? For example, if I do a plus b and then I do b plus a, so it's a different path, then I should end at the same result. Okay, another one is called there and back again, which is the typical symmetries. This is for if you have serialization, if you have like addition and subtraction, write and read. Oh, there's a plane, great. So you have set property, get property, you have insert, contains, create, exists, and so on. In fact, a funny story about symmetries. I remember in the 7th grade or something, we had it was a math exam, and there was an equation that you're supposed to solve, and then I made a mistake on both sides of the equation, right? So it's basically like the symmetry. So the symmetry is not going to find bugs on bugs for the basically the matching bugs, right? But it is gonna find the other ones. So basically, I had a sign error on both sides. So on one side it was a 4, and on the other side it was a negative 4. But actually I flipped the side, like somehow I managed to get a negative 4 on this side and the positive 4 on that side. So my result in the end was correct. And in fact, I talked to a buddy of mine, after the test, and I was like, hey, what did you get out? And he was like 27. And I was like, oh, I got it as well. But in fact, I didn't get all the points because I made the symmetry mistake. But it's still very valuable. So he calls it there and back again. The next one is some things never change. This is about structural perseverance. Like, for example, if you have a list of 10 elements and then you map them to something, then whatever you map them to, in the end, the list is still going to have 10 elements. Right? So you transform something, but the property didn't change. The next one is the more things change, the more they stay the same. So this is, for example, if you do distinct or if you do a sort, and if you do it multiple times, it's going to be the same one. The result's going to be the same as doing it one time. And by the way, I also believe that this is basically, doing something, that's very, very related to different paths, same destination, right? So doing something twice is basically one path, and doing something once, it is actually another path. So you still have the same result. Okay, the next one is solve a smaller problem first. This is like typical sorting, or for example, if you have a binary search tree, then it doesn't matter how big it is. This property that the elements on the left are going to be smaller than the elements are on the right is still going to be held, right? So the same property. So the typical I want to say command and conquer, divide and conquer. Okay, hard to prove, easy to verify. It is actually very similar. For example, if you have a list and you sort it, and then you compute the sliding window over that list. So, for example, if you look at at the tuples in that list, then the tuple that is on the left is going to be smaller than the element that is in the tuple on the left is going to be smaller than the element in the tuple on the right. And you also have the test oracle. This is where you have a test system and the production system, and you compare the results. But again, I believe that this is basically the same as a different path, same destination. Okay, so you either go through the real system or you go through a test system. The results should be the same. Notice that most of them are actually based on some mathematical structures or some mathematical laws. And again, this is happening because this property-based testing has its roots in functional programming, which has its roots in math and in lambda calculus. Like, for example, different path, same destination. This is commutativity. Then you have the there and back again, which is invertibility. Then you have some things never change, which is structural perseverance. Then you also have induction properties of the more things change, the more they stay the same, and so on and so on and so on. So there's a lot of mathematical things out there. So this happens actually very often if you write your example-based tests. Then you actually figure out that you figure out some relationships, and then you figure out, okay, I'm just going to write a property-based test for it because now I figure out that there's some property behind it. And usually these properties, they have their roots in math, right? Like commutativity, associativity, invertibility, and all of these beautiful things. All right, that's all I got for you today. Sorry that this video was so long again. Have fun with ScalaCheck. Remember that it was not my intention to cover the entire library. Consider scrolling through the user guide. You will find, for example, that I didn't mention how you can label your properties, or how you can see the distribution of the values that ScalaCheck has generated, and so on and so on and so on. Just go and have fun with it. Okay, as always, it's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you find my videos valuable, consider supporting me on Patreon. But as always, most importantly, take care.